So this is how you would solve number 4. I'm making this in 2 parts, the correction. And so the last angle would be 60 degrees. And I'm just using what did I use here? Sum of triangle. Sum of triangles equal to 180. There we go. Moving on. We have the determine the value of x, then calculate the value of angles A, B, and C. So we know that this is a 1, 2, 3, 4, 5-sided. So the sum, without any further calculation, is 540 for a pentagon. You should know this already. And so all you need to do here is basically say that 2x, let's start with 2x plus 2x plus 3, technically in brackets, but because we're adding, it's not needed, plus 2 times 90. All of that is going to be equal to 540 degrees. It should be. And then so you add your x's here, 2x, 2x, and x. That'd be 5x. And then we add our numbers, so 3 and 12 is 15, plus 180, that's 195, is equal to 540. 5x is equal to 540 minus 195. 5x is equal to 540 minus 195, which is 345. Divide both sides by 5. You get 69 degrees. All right, so that this would be, by the time you get to this, you would get 1.5 marks out of that. The fact that you needed to know this, all the arithmetic that is involved, so that's that. So then angle A would just be 69 plus 12, and that is 81. B is 2 times 69 plus 3, that's 141. And angle C is 2 times x. So that'd be 2 times 7 is 140, so 2 less than that is 138. So half a mark for each of those. And so if you got this wrong, but you plugged in correctly, you still have a chance to get 1.5 there. 5, Jamira's measuring the exterior angles, right? Important, of a convex octagon. We're not told it's regular, and you can clearly tell it's not. What is her answer reasonable? Explain. So what I'm going to do is sum of exterior angles should be 360. So let's check. 45 plus 47 plus 52 plus 49 plus 42 plus 38 plus 51 plus 48. That would equal to 372 degrees. I will check it one more time. Oh, I get 392 when I do it again. 49, 42, 38, 51, 48. I will pause this and do a check. It checks out to be 372. So sum of exterior angles of the octagon in this case do not equal to 360. Therefore, answer is not reasonable. Something along the lines there. Determine the following for a 37-sided polygon. So the anterior angle would simply be 37 minus 2 times 180 divided by 37, and that is 170.27 degrees. 1 mark. Show 2 ways to calculate the measure of the exterior angle. So you would have 360 divided by 37, and that's 9.73 degrees, or it's 180 minus 170.27, which is, just checking, 170.27 degrees. So it's either this, oh, sorry, 9.73, my bad. I'm looking at my calculator here, and that's what it's showing. I just didn't write it down correctly. So 973 is the answer. Easy enough. How many sides would a regular polygon have if each interior angle measured 176.4? I will show you both methods just in case. Exterior is 180 minus 176.4. Okay. So you get 3.6 degrees there. So we know that the exterior angle is 360 over n. The exterior angle is 3.6 degrees, equal to 360 over n. Put the 1 here, cross multiply and divide. It's 360 times 1 divided by 3.6 degrees. And that is going to be 100, right? So 2 marks if you show the work there. I guess I'll show you the longer method. If this is your interior angle, this is the formula for finding the anterior angle, and I'll show you how this is a lot trickier. So 176.4 degrees is equal to n minus 2 times 180 over n. So the first step would be to multiply both sides by n. So you get 176.4 n is equal to, this cancels out. Then you have to distribute. So you get 180 n minus 360. I'll bring the n over, so you have negative 180 n plus 176.4 n. That is equal to negative 360. You combine these, and you get 3.6 negative 3.6 n is equal to negative 360. And there you will see that it will look very much like the other side. You divide both sides by negative, that is, and that turns this side positive, which is what you want. So it's 100 sides. Okay, regardless of how you do it. Renzo's working with regular polygon tiles, all with the same side lengths. Basically, this tells you that anyways. More specifically, he was working with dodecagons, hexagons, and squares. Could tiles of these 3 polygons cover a surface? Explain your answer supported with calculations. So I'm going to find the interior angle of squares, which is 90. Interior angle of a hexagon is 120. If not, you just calculate that, not a big deal. And dodeca, right? That's okay. And so there I have to use a calculator, so it's 10 times 180 divided by 12. It's 150. And so you basically start with 360 and you subtract 1 of each, right? So there's your square. And so that gives you 270. Subtract a hexagon. And that is 150. Oh, perfect, right? And then it's minus 150 for the dodecagon. And that's 0 degrees, right? So yes, you can cover a surface using one square, one hexagon, and one dodecagon will tessellate. There you go. That's it. 1 mark for the work and 1 mark for your conclusion. A gas refinery stores oil in spherical tanks. The current tank can hold 1,500 cubic meters of oil and has a diameter of approximately 7 meters. The refinery plans on making a larger tank which can hold more. So that's a new. This is the volume of the new, and this is the volume of the original. And so determine the scale factor used. So the scale factor is going to be found by taking the cube root of those volumes. And it's volume of the new one over the volume of the original. Okay. And that gives you, actually, you can probably just, cancel trailing zeros. So it's really 120 over 15 if you want. If you didn't catch that, that's okay. So that would be cube root of 8, which is 2, right? So a scale factor of 2 has been used. So the tank, the new tank is twice as big, but it can hold 8 times more, right? A factor of 2 cubed is how the volumes are affected, right? Like just by you're actually making it. So if you have your original, right? If this is your original sphere and this is 7 meters, if you're making a larger one, right? And that one is now obviously 14. So the linear dimension, right, from here to here has been affected by a scale factor of 2. The volume from here to here has been affected by k cubed, which is 2 cubed, which is 8. The volume has been affected by 8. So surface area, if you wanted to like if I asked you for the coating around that sphere, right, that's covering that surface area, that would have been affected. How much more paint? 2 squared, right? So 4 times more paint needed to cover it. So volume is k cubed, area or surface area is k squared, and linear dimensions are just k, right? What would be the diameter of the larger tank? So I wanted you to use this one, right? K is the diameter of the new over diameter of original. So it's a linear thing. And so now that you know that this is 2, diameter of the new is unknown, and the original is 7 meters. So it's really just, if you put a 1 here, cross multiply and divide like that. So diameter of the new is 7 times 2 divided by 1, which is irrelevant. That's 14 meters. All right, and that's it for the test. If you want to hang around for the bonus, you can do that. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's a 16-sided shape. So I will go proceed and figure out my interior angle. And that is 157.5 degrees, right? Okay, so A, therefore, will be found by going, what is this? 1, 2, 3, 4, 5. It's a pentagon, so it's 540 minus 3 times 157.5 divided by 2. Divided by 2, you get 33.75 degrees. Okay, And then for B, I have to be careful here because it's a 1, 2, 3, 4, 5, 6. It's a hexagon. Irregular, that is. So it's 720 minus 1, 2, 3, 4 interior angles divided by 2, right? Because you're splitting that remainder amongst that. So 720 minus 4 times 157.5. That's 90 divided by 2 is 45. You have that, and to find C, there's a number of ways you can do that. The easiest would be just to consider the interior angle, which is 157.5, subtract, oh, we don't know this one, sorry. I thought I had made you find that. Nope, nope. I wanted it to be harder. So as you can tell, it's basically just my checking. I check if everything works out. So C and C are the same. So here we have 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon. So angle C, the octagon adds up to 1080 minus there's 1, 2, 3, 4, 5, 6 of the interior angles that we found earlier. All of that divided by 2. 1080 minus 6 times 157.5 divided by 2, that's 67.5. There we go. That's what I was after. So those are your 3 angles for a bonus of 3 marks. All right, that's it. That's all.